So I'm just going to read a brief bio and then say a few words and then pass it off to Golan. Golan Levin is an artist, engineer, and educator exploring the expressive potential of computation. His interactive works merge art, code, and design to reveal new forms of communication and play. Graduate of the MIT Media Lab, he is professor of electronic time-based art at Carnegie Mellon University, where he directed the Frank Ratchey Studio for Creative Inquiry from 2009 to 2023. Levin's projects include the Free Universal Construction Kit and Augmented Hand series, and they have shaped the field of creative coding and inspired generations of digital artists. So I just have to tell you, I first met Golan. Golan was actually a critic for my thesis show here at RISD in digital media. In 2009? In 2009, I think, is when I first met Golan. And I was so excited with the creation of the new department. You know, all of you, especially the first sort of CTC cohort going into CTC, this kind of question of like, okay, I'm going into this major. What am I going to do with it? Right? There's so many avenues and so many ways of thinking about what a life in creative computation might look like. And the thing that's so cool about Golan is he embodies so much of that, what I would call like creative independence in kind of computation and digital arts. So I want to point to a few things that I think are like really core for, I just want all of you to think about moving forward. The first is like any open source project, any festival, any media thing, any school, anybody you talk to, Golan's name will pop up. Golan is connected to everybody because he supports kind of community building. Because I'm old. Yeah. But I will say it's like that kind of like open source ethos, community building ethos, you know, hosting the processing foundation. I don't know how many times hosting syllabi workshops, teaching workshops, his books. So just so many different ways in which Golan has shown, you know, how to maintain that creative independence, whether through education, through design, through art. There's not just one model, there's a million models. And I think Golan can talk to a lot of them. And so that's why I'm really excited he's here to kind of give you a really exciting vision, at least for you first cohorted from CTC where it might go. For the rest of you too, I'm assuming. But so please, big round of applause for Golan. Thanks for being here.
Hello. Hi. Hi, everyone. Nice to see you again. I spent the afternoon in a workshop with many of you. It failed at the end. I'm humiliated by it. I hope to make it up to you this evening. I'm thrilled to be here, and I want to congratulate both you, the students, and also Clement and Daniel and the others, Nick, who are teaching this new program. Congratulations on being the pioneers to make this happen here. It's really exciting. You're in a beautiful space. You have fantastic talents and amazing educators, tremendous resources. And I am very happy for you that you have this opportunity to kind of like pioneer this thing here. Congratulations. This is great. These are the good old days. And as terrible as it is to be here right now in the world, I support each other. So at the outset, I want to thank you guys for taking the time to come out here today. It's a uniquely challenging time to be a student, to be an educator, to be a creative person, to be a goddamn human being. And as an artist and exploring, who's exploring and developing your own peculiar vocabularies of form, it can sometimes be unclear about how your work matters. I assure you that it does. You're showing people that there's something to value besides money. You give us a dream that can, relieve us from the nightmare. In return, I hope that you'll come away from this talk with some inspiration too. But I'm inspired by all of you for the energy that you bring, and I hope you guys can support each other. We are working in art and technology, and I'll be showing today some projects by myself, my students, my friends, my peers, not just myself. It's going to be a long talk, but I promise it'll be entertaining for you. And I want to emphasize that these projects that I'm going to show today were often made by single individuals or tiny teams of like 2 to 3 people. I want to show this, what people can do when it's not this is an important contrast to projects, as you see, that are made by big companies. I want to show us what's possible to do as a single person or just, a couple of friends that you're with. So many of the projects I'll show were made by small teams of small people, often using open source code made by artists for artists. And as it sort of fits like right now where we're at in the world, I'll be focusing on some AI techniques, which was part of my workshop today, but things like computer vision and generative neural networks, recognizing that such technologies were and continue to be developed for military purposes, as so many technologies are, that the artists who use these tools could be described as bottom feeders on surveillance technology. And this way of working has a long history in computer art. And I think my goal, and perhaps many of you as well, is to kind of drag the most arcane debris of the tech revolution into some kind of realm of artistic expression. A mentor of mine, Michael Neymark, has thought really deeply about what it means to operate as an artist in the context of high technology and have a technological research environment. Michael was the first person to tell me in 1994 that my field had a name, new media art. This was a really potent revelation for me in the time before search engines existed, and it connected me to a like-minded community of people at a time when being an art technology hybrid felt impossibly lonely. So some years ago, Michael wrote this article called First Word Art, Last Word Art, which I still share with my students, and I encourage you all to check out, about the joys and perils of working with new media, right? Where we're sort of jostling to explore the recently possible, but also paradoxically yearning to make something timeless. And in this article, Michael contrasts artists who sort of seek to get the first word in, like by exploring some new things now possible, versus those who aim to get in the last word, by making something kind of enduring within well-understood forms. And in the context of first word art, I've long argued that artists need to claim a seat at the table in defining technological agendas. That's kind of what you guys are training to do. In reimagining what our tools should do and what sorts of new worlds we want to bring into existence with them. This is more urgent than ever in relationship to machine learning and AI tools, which we know for a fact are being used for extractive exploitation, surveillance, redlining, and genocide. And it's sometimes difficult to imagine how to respond to these technological trends without just kind of shutting down entirely. As artists, I feel we have a duty to explore the culture of computation, as Myron Kruger has said, and to take up these technologies in the service of aesthetics, in the words of Caroline Jones. Whitney Sparazza has likewise pointed out that what we think computing looks like has been dominated by figures from science and technology. And there are already contributors to this history from the arts especially, whose important contributions have been overlooked. You guys are beginning to make contributions in this space, and I think the challenge is to explore technologies as artists do without becoming complicit in the ways that they are ruining the world. And this goes both ways, right? Just as code literacies have long been deemed essential in arts and humanities spaces, we've all been subject to the everyone must learn to code rhetoric. I also insist on advocating for and cultivating arts literacies in scientific and engineering spaces, which desperately need more well-rounded understandings of what's worth making and why. So I thought I'd show some of my work tonight, and I'd open up with a project from 2003. This was a performance called Messa de Voce, which means sending the voice, which visualized the songs, shouts, barks of two experimental vocal performers in a real-time cartoon projection. These are performers, Joan LaBarbera and Jaap Blanc, who are world experts in making unusual sounds with their mouths. And the software was created in collaboration with my good friend and former student, Zach Lieberman, and produced at Ars Electronica in Linz. And so the software was inspired, the project was inspired by this animation by a Czech animator. Her name is Michaela Pavlutova, called Rechi, 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 which means speech, speech, speech. And I was captivated by the fiction she presented of visualizing the voice. Here's a quick 2-second clip. So that's an example of kind of this animation that I saw in the late 1980s, and I was like, or early 90s, and I was like, this is great. What is that like? So in our performance, an interactive projection was constructed from about a dozen different scenes, and like this one here, which presents the fiction that speech casts visible shadows. And the way the performance operated was that the vocalists are standing in front of a gigantic projection, while a computer vision system is here tracking and locating their heads. A voice analysis system is analyzing the sounds that they're making, and the projection made graphics that were tightly coupled to their speech or songs and projected so as to appear to emerge from their mouths. So in addition to the bubble scene I just showed, there were many other metaphors, such as a voice-sensitive environment, painting with the voice, and I'll show some examples here. In this scene, Yap is making this sound he calls the cheek synthesizer, in which he's making little flappings with his cheeks like this, right? And every time his cheek flaps, it makes a little ball come out of his mouth or out of his head. This is what he does for a living. So there's more to it, but as you see, there's other scenes as well. And in this one here, there's a voice-sensitive costume. So in this scene, Joan was performing as a kind of a creature, and then Yap is a kind of a David Attenborough style nature narrator who's describing, the characteristics of this animal with kind of abstract subtitles. It's a nonsense language that he's making up on the fly. So in 2000, this is just many different scenes in the performance. In 2004, we adapted the software specifically into an interactive installation to allow the public to experience the software directly. Here are two kids painting with their voices. And the important thing about interactive installation is how it allows the visitor to discover their own potential as a creative actor. This kid is kind of discovering an inner monster. Okay, I'm going to now kind of introduce the talk in general. The central thread of my talk today is generativity. So the idea that art that makes art. And sometimes this is called meta art or algorithmic art or art machines. Ars Electronica curator Gerfried Stocker has called generativity one of the four pillars of new media art. The others are listed here, along with transmediality, connectivity, and immersivity. And all of these are interesting. I'm not going to focus on them today. I confess to being a generalist who works in the media field, and I've worked in all four of these areas. But my focus today is generativity specifically. And I'll also announce up front that I'm going to talk about this topic a bit imprecisely, kind of breezily moving between procedural notions and, let's say, statistical modes of generating media. After half a century in the shadows, it feels like it's finally time. The last few years have been a really incredible heyday for generative art. So I'll show some of mine. As an example, last year I created this project called Cytographia. It's an elegy for species that we will never know or never know again, expressed through generative illustrations from an imaginary book about imaginary organisms. Here are 18 different runs of the software. An infinite number are possible, but a total of 418 were published through an online gallery. And every aspect of this illustration is generated through custom code, including the anatomy of the depicted creature, the nonsense letter forms of its labels, the virtual paper on which it's rendered. In this sense, it's an example of a kind of classic pre-AI kind of generative art, explicitly coded with rules and algorithms that I've designed and programmed. Here's kind of a video recording of what it looks like. It's dynamically animated in real time. It actually presents an interactive diagram of a one-celled microorganism, sort of styled to evoke a hand-drawn engraving. And so this is a recording of me kind of interacting with it. And these cell structures that are there arise, have movements that arise emergently and in response to real-time user interactions. So according to a recent estimate, there are about 1 trillion species of microbes on the Earth, of which 99.999% have yet to be discovered. But experts have also calculated that as much as 0.1% of all Earth's species are becoming extinct each year. If these estimates are accurate, then between 100 million and 1 billion species of microorganisms are becoming extinct each year, the vast majority of which are undiscovered microbes. This project offers a generative speculation on what these vanishing life forms might have been like to observe and interact with. So there's a bunch of these. You can play with them online and also just hit a button to make a new one. Okay, so it's 2025, and you're probably familiar with generative art that looks like this, right? Or even better, this is already kind of old now. These are collisions of text and image that underpin AI-based prompt work, like nuclear explosion, gender revealed party, or Kermit the Frog testifies before Congress, 1953. These are the products of a dialogue between critical imaginations and a sophisticated tool of unknown potential. And they reflect unique human perspectives. I'm not fascinated with the tech, but I am fascinated by our ability to find unexpected ways of using it. In 1965, Max Spencer outlined the goal of generative art. So I guess 60 years ago, or more. To accelerate our ability to produce deviations from the norm. Essentially, an artist makes a system to probe aesthetic possibilities that they couldn't themselves predict. Vera Molnar called her generative drawing programs machines for serendipity. Computational poet Alison Parrish has called her poetry generators cute robot explorers for semantic space. We, artists, bottom feeders on the arcane debris of the tech revolution, have adapted AI, the ultimate apparatus of surveillance and social control, to instead probe the outer quantiles of aesthetic experience. All around us, however, the opposite is now happening, right? Here's a fungible nugatory image, one of the less offensive AI artworks that come up in the first page of Google results. The author of this statistically likely artwork in his license field spells out its value. It's AI generated, he writes, so do whatever you want with it. Thank you. I'll debase it in a public talk. 60 years on, with seemingly all of visual history encoded in data sets like Lion 5B, which is 5 billion images, we're all pulling from the same distribution now. And the increasing adoption of AI is accelerating to a sort of a race to the middle. And as Kyle Chaika has pointed out, the algorithmic feeds of social media have pushed content creators to conform to the acceptable average. AI generation will automatically produce that average from the start, pushing us into an era of average garbage forever. And that's the challenge, right? Can we use these things to get out of that? In his essay, Defining AI Art's 3 Proposals, Lev Manovich explains that many people define art created by an AI as something that arts professionals recognize as valid historical art. Thus, the achievements of AI arts during the last 6 decades are convincing simulations of historical art created before AI art making started. By this retrograde definition, AI art is not capable of executing the main strategy of modern art, which is constantly expanding what counts as art. So we have to shatter this. Straightforwardly, AI can be used in processes, situations, and performances that expand the definition of art. I think the 2 Circles robot by Magdalene Gannon does this joyously, but there are plenty of other approaches too. And if we are image makers, we have to cultivate and vigorously protect our ability to work outside corporate tools, which are only ever designed to support the creation of familiar things. One of my favorite AI artworks of all time is this collection of dreamlike leaves I showed you earlier that Helena Sarin created in 2017. Crucially, she created these by training a self-made neural network on 1,000 images of leaves that she collected from her own backyard. A deeply personal AI practice that seems almost quaint now in our era of stupendously large ready-made data sets of dubious provenance. In Why AI Will Never Write a Great Song, Nick Cave, the musician, explains that part of what moves us in appreciating art is not just its specific perceptual patterns, but our kinship, awe, or empathy for the artist. For Cave, art cannot be separated from the person who made it, and what makes an artwork good or compelling is more than just what it looks like. There's a new kind of creative voice, absurd and charming, that guided the otherworldly post-photography of Sawdust Store. Right? It's a person's voice, it's funny, and I'm here for it. I think it's hysterical. sawdust store, but because of it's somebody's joke, and I want to know that somebody, that's a real person. I see it in this ecstatic fantasy. Billionaires at La Tomatina Festival. It's a Spanish tomato throwing festival. It's real. As modest as this work is, it demonstrates a new type of byproduct of human curiosity, human desire, and human critical understanding, empowered by a new slingshot for the mind. I think these works point towards the conclusory definition of AI art, which Lev Manovich posits in his previously mentioned article. AI art, he writes, is a type of art that we humans are not able to create ourselves because of the limitations of our bodies, brains, and other constraints, but which, as all great art before, expands our creative potential as humans. So AI looms large in our understanding of generativity, but I would argue in a very narrow way, it seems to be that popular notions of generativity have coalesced to a kind of singular point. Deep learning-based text-to-X systems make text get something out, exemplified by Midjourney and Runway or Stable Diffusion, in which images are conditioned by text prompts, or if you like, sort of invoked by incantations. Lillian Yvonne Bertram has pointed out that despite, or perhaps hand in hand with, the unholy biases built into these systems, they're also nonetheless full of inspiring slippages and weirdness. But this savory weirdness becomes ever more elusive as these systems are predictably honed for photorealism and advertising. I'm already nostalgic for the AI systems of 2 years ago. Also, prompting-based generative systems privilege the describable, right? I'd like to talk now about some alternative and potentially overlooked forms of generativity. That's going to be sort of the rest of my talk, both in my work and in others. So in introducing a discussion of generativity in AI, it's really kind of worth considering one of the very first international group exhibitions of computer art ever, the legendary Cybernetic Serendipity exhibition organized by Yasha Reichardt in 1968 at the London Institute of Contemporary Art. The dictionary says serendipity is the development of events by chance in a happy way. I submit to you that the computer as a tool for the production of serendipity, which is to say surprise, wonder, and magic, has been an abiding theme in computational arts for the past 60 years. That's right, computer art is older than acrylic paint. It's frequently been said that once AI works, it's no longer intelligence, it's just engineering. From my perspective as an artist educator, it often seems like everything must be shoehorned into something productive. But making something for productivity, precisely the very force that warps AI into engineering. As a human, I may or may not recognize an alien intelligence, but I know what it isn't, and that's the automation of a mundane task, right? If someone or something makes me question what I think I know, then that's a sign of their intelligence. So aspirationally, I believe that the job of AI is to help us find serendipity, to help us find this kind of surprise and wonder. Alison Parrish, quoting her again, has even issued the wonderful challenge that that art is the only ethical challenge, that art is the only ethical application of AI. In a recent talk, Bree Pettis, who makes these plotters that you guys have been using, discussed his philosophy for doing things, and it's simultaneously a great specification for serendipity and also generative art in general. Decisions made without enough information but good intention have the most interesting outcomes. So I want to talk then about some different approaches to generativity. And artists' force multiplier, something that gives you more like this, please, is a great place to start. I hope you guys know the work of the great Vera Molnar, who died last year at the age of 99, but was active until the very end as a generative artist. She was really one of the first dozen or so people to ever make art with the computer at all. This is some work of hers from 1968 called Interruptions, which is one of her plotter works. And here's more of her work from 1974. Her work is a particularly good example of how generativity was explored during the first half century of computer art, right? The artist writes a program that renders a form. The form is characterized or parameterized by variables designed by the artist. Change the values of these variables and the form changes. The artist can link these to randomness or gestural inputs or link them to streams of data. She's created an artwork here, like a software that makes artworks that are prints, right? If she wants more like this, she just runs the software again, right? So different runs of the software produce different runs. Here I've recreated her project shown on the left from 1974 with 35 lines of P5.js. This is meant to be an homage, but also kind of a way of understanding a masterwork by recoding it from scratch. And I presented this earlier in the workshop, but one of the more commonplaces, types of generativity, particularly with AI, is a form of bootstrapping automation. right? Kyle McDonald has described AI as programming with examples instead of programming with code. And the goal of feeding such examples to the AI is to train it to obtain more like this. So how do AI systems work? Well, we know that the artist working with neural networks does not specify the rules. Instead, she specifies the inputs and outputs, providing thousands of examples, and allows the network to learn the rules to describe the transformations that get from one to the other, right? We provide thousands of pairs of, let's say, color and black and white images, and it learns the rules to convert not only color into black and white, but weirdly enough, to do the reverse, so that we can synthetically colorize, grayscale images with statistically likely colors. When they need to invent information to do this, which we sometimes call AI hallucinations, they're getting the colors or the details, to go from blurry to focus, right, using inferences from thousands or millions of examples. What's interesting then about AI in the arts is that artists are still developing programs that render a form. The form is still characterized by variables, but the difference is that these variables are no longer specified by the artists themselves. Instead, the variables are now deduced directly by the system and the training data that the artist provides. And what's especially interesting is that these variables control perceptually higher order phenomena, not the number of cells in a grid, but things like leafiness in different ways. So the artist's job becomes one of selecting or creating training sets. And I was thrilled that one of you came up to me after the workshop and they were like, how do I train my own data sets? Because you're right, that's really where it is. Data is the source of where it comes from. I mentioned this project by Helena Sarin. She's trained her own synthesizer for these leaves that she's collected from her own backyard. But the machinery produces serendipity and surprise, right? A leaf with two stems, for example. I pointed out earlier as well, when the training sets are too small, we actually end up with this kind of serendipity of weirdness, of weird problems that are actually kind of beautiful in the kind of problems they reveal. So this is an older work by Janelle Shane, where she's trained up an AI on images of cats. But as you can see, like many images of cats have meme data in them. Many images of cats have people, but not enough people to actually get a realistic understanding of what a person looks like. And cats are so variable that when a training set is small, it can't capture that variability, and therefore misinterpretations show up as to like the kind of shapes cats have. By today's standards, in which AI models are trained on billions of images, right? This looks downright primitive, but it reveals the biases that are still there in our AI system, just harder to spot nowadays. Here's some mildly edgy work by the Brooklyn collective called Mischief. And this is an animation from their project called This Foot Does Not Exist. So you text a provided telephone number and visit the website, receive text messages containing novel images of synthetic feet generated by an AI. The artists note that images of feet simultaneously operate in two distinct modes of cultural consumption. They have all the transgressive qualities of traditional pornography, but they have no actual explicit content. I can show them to you here in a mixed crowd, right? Thus, the foot pic is both highly valuable to some people, right, and almost entirely worthless to many others at the same time. So exploring this weird contradiction of the foot pic as a commodity, the Mischief Collective uses AI as a tool to make more like this, please, in a kind of transgressive way. I'll show one of my projects as well. Exploring the use of generative AI to create more like this, please. It was early 2021, deep in the pandemic. It was a dark time, and I started working on a personal project, a series of grotesques, which were meditation on themes of illness, social unrest, and identity. Especially, I was thinking about the identity of toxic white masculinity, which fueled the January 6th insurrection in the United States in an attempt to thwart our lawful democratic transfer of power. And I was also thinking about ambigrams, which are these topsy-turvy images that are legible both upside down and right side up. Some of the best known ambigrams are a series of reversible faces by Rex Whistler, created in 1931, and a collection of upside down pictures in the 1860s by Utagawa Yoshitora. The illusion has even older roots. In the 18th and 19th centuries, bivalent face illusions were often used to depict conventional and seemingly uncomplicated dualities, such as young, old, happy, sad, good, wicked, male, female. So in collaboration with my student Ling Dong, I synthesized a collection of 55 ambigrams, which can be displayed and viewed in any orientation. The system works by finding upside down faces in the latent space of right side up faces. And in the struggle to match upside down face using right side up ones, the AI tends to converge on a face that can be looked at both ways. It's a coincidence, but such a face is often, like myself, a man with a beard. So the faces in this project reflect the moral ambiguities of a darker and more uncertain time, marked by misinformation, identitarianism, social unrest of a polity divided against itself. It's a variable format work. When the faces are offered as still images, I show them sideways to preserve their ambiguity. In time-based media, I present them as bivalent videos, puppeteered by facial motion capture recordings and reanimated by an image warping algorithm. Pick your pick. It works both ways. The main purpose of the project was to create this tangible, open-ended deck of poker-sized cards. Participants are encouraged to devise their own activities with these cards, kind of printed interactive form, such as sorting them according to subjective criteria or giving them names and epitaphs. And here you can see the sort of interpolation procedure by which the faces were made. As I said, it tends to converge on a face that can be looked at both ways. You give it an upside down face as a query, and it tries to do its best to find a face that matches that. So some other generativities. Generativity through interpolation, interaction, feed, behavior. Let's just jump into a bunch of these. Interpolation. Many of the abiding concerns of the artist and cybernetic serendipity, that 1968 exhibition, are still with us today. So I want to begin with the example of interpolation, which is this notion of kind of visualizing the intermediate states of a transformation, right? In MC Escher's artwork, you know, the value is not so much the beauty of an individual fish, right, but the artist's magic trick in kind of being able to transform from one to the other. This concept of metamorphosis has its roots in nature. Who doesn't wonder at transformations like this? You know, what's going on there, right? In which, you know, what happens inside the cocoon privately and away from our eyes. You know, secret, the bug is actually in a liquid form. Pretty wild, right? Transformation is not just a natural wonder, but often a symbol of the supernatural. First miracle in the New Testament is one of transmutation, in which Jesus interpolates water into wine. I have to wonder, what does it taste like right there? Right? Is it like spritzer? Somewhere because it's just diluted, you know, wine, like someplace in between, right? You know. The thing is, it's not enough to know that a transformation has occurred. We want to savor seeing how the transformation takes place step by step to appreciate and understand its mysterious details. We want to see some intermediate stages to see inside the cocoon. This is a political cartoon from 1831 in which Charles Philippon had become, it was sort of one of the first viral memes actually in Europe. Previous to this, he had been jailed by the king for making a political cartoon that resembled the king, but which did not actually label the king by name. So in response, when he got out of jail, he made this sequence here in which interpolation is a political act. The first sketch he wrote looks like the king, so would you arrest me for it? Under the second, more abstract one, he wrote, so then it would be necessary to condemn this one, which resembles the first. By the third drawing, it was looking like a pear. So nonetheless, he wrote, well, then condemn this one too, which looks like the second. The fourth drawing is unmistakably a pear, right? And he concluded, and finally, if you're being logical, you would not be able to excuse this pear, which resembles the previous drawing. So for a pear, would you punish their author with 5 years of prison, which is how long he was in jail? As a bonus, the French word for pear, poire, also means a fool, right? So whether producing still image sequences or animations, the computer is the ideal tool for visualizing these in-between states of form, right? How else could one produce the covers of Animorphs, popular series of books appropriately written enough for tweens, right? Who are themselves grappling with wild and frustrating changes to their bodies. Here's a boy who turns into a dog, a girl turns into a starfish, right? Or perhaps the reverse is puberty, right? It's like this is what it's all about. And when used with pixel-based images, this interpolation technique is called morphing, okay? The first technology for which was invented by Nancy Burston when she was an artist in residence at MIT in the late 1970s. Her software was face-aware, with representations for hand-coded landmarks like eyes and noses, and it had the ability to produce weighted blends between aligned images. For her, producing the transitional states between specific examples was an instrument for understanding and deconstructing entire categories, in this case of female beauties, Okay, so on the left is an average of female beauties from the 1950s, and on the right, a more of female beauties from the 1970s, trying to understand time developing notions of female, how beauty is represented in the media. So in my next slides, I thought it would be nice to consider the early history of visual interpolation on the computer. And some of the earliest computed transformations study the relationship of form to randomness, right? And explore the progressive dissolution of a single form due to entropy. This is a famous 1968 work called Schotter or Gravel by Georg Naes. It's really like a classic, landmark piece of media art, computer art. And I've recreated it here in 34 lines of P5JS. Kind of ideal project for beginning creative coding students. It teaches topics like randomness, iteration, and how to position basic visual elements. But this notion of transformation from chaos to order was a huge abiding theme in early computer art. This is an example of a plotter drawing made in 1967 by Chuck Suri and James Schaefer. And the scan here is from the Cybernetic Serendipity catalog. This is called Chaos to Order, showing this kind of hummingbird exploding. Likewise, their project from 1967, Aging Process, right? A drawing rendered on a drum plotter. It's an attempt to see an evolution that happens to all of us, person changing from young to old, but it fails to work as you might hope or expect and it's full of glitches because the marks are not well parameterized. Other works shown in that Cybernetic Serendipity exhibition consider the relationship and contrast of two forms, translating from one to the other, without the influence of randomness, right? So this is a Return to Square by Masao Komura and Kunio Yamanaka, who are members of Japan's CTG or Computer Technique Group, a really early posse of people exploring the creative potential of the computer in Japan. So here the ideal form of the square is metamorphosed into the organic profile of a woman and then returned to a square again, also from Cybernetic Serendipity. The computer really comes into its own when we ask it to show the intermediate states of otherwise impossible or unknowable transitions between forms that we know well. This is a lovely computer artwork called Fruit Salad from 1970. At the corners are a platonic apple, lemon, orange, and a chestnut, but inside the square, the computer has produced uncanny mixtures. Interpolating between well-parameterized forms is easy when the artist has deliberately created those parameters. This approach is at an apex in a project like Jason Salavon's 2009 Still Life, in which a constantly evolving skull is moving through different geometric mixtures of bear, human, baboon, and boar, right? This is sped up 500 times, by the way. He presents this as a kind of a very slowly evolving painting kind of still life. He's made this work by creating a manipulable 3D model of a skull with specified key points for the eyes, canine teeth, etc. With machine learning, then, the parameters of forms are not directly specified by an artist, but rather indirectly inferred by the artist's AI system. Generative AI systems capture properties of images in a multidimensional space called a latent space, right? And when a neural network is trained, it produces this latent space, a multi-thousand dimensional mathematical representation of the ways in which something varies. These dimensions correspond to the primary modes of variability in that data set. So to unpack that, these dimensions might encode, for example, visually salient continuums for things that properties for which we sometimes but not always have names. In the case of a face, these dimensions might encode properties like looking left or looking right, looking up or looking down, smiling or frowning, young or old, male or female, mouth open, mouth closed, dark skin, light skin, no facial hair, long beard. These latent spaces can be sampled to create novel images that represent mixtures of these continua, right? As in this music video project by Mario Klingemann, in which movement through facial dimensions is controlled by parameters from music, such as loudness. And on the right, Crystal Ding has created an AI on a large collection of images of herself. She's trained her own model, and she uses it to create these kinds of strange interpolations that represent fluctuations in identity, right? Again, she's only using a couple thousand images of herself, so she's not able to reproduce a kind of perfect image of herself. Instead, she creates this kind of mushy meat form that when she moves through it, it does its best to kind of do what it can, but the imperfections are really where it's happening. For her, the Crystal Ding, the navigation of latent space is itself a type of metaphor artistic practice. This is work by some students of mine for whom latent space navigation as a kind of immersive real-time experience is a bit like surfing, right? So my students, Gray Crawford and Aman Tawari, created this project called Zoromancy, an interactive artwork that allows visitors to explore or perform an image with gestural movements. Their hands are being tracked by the leap controller, and the leap motion sensor maps the movement and rotation of the hands and fingers to a sort of high-dimensional AI latent space. All right, so here's generativity through interaction, amplifying gesture. This is a German toy called Nasenspiel or nose play. It's a printed disc about 2 inches across with a small wiggly black chain. You shake it and it produces new noses, shaped through a negotiation between your own gesture and the randomness of physics. It's a classic open-ended generative system, as Umberto Eco describes it, an open work, right? That invites the audience to interpret it in multiple, potentially unending ways, and allowing for personal interaction and interpretation, making the audience an active participant in the creation of the art with meaning. And I've been making gesturally interactive systems for the past 30 years. It's something I continually return to. So I thought I'd show one of my own projects from 1997, which has been a processing demo since 2000. It's an interactive system for the gestural creation and performance of real-time abstract animation. It repeats a user's gesture end over end, enabling a person to simultaneously specify both a line's shape as well as its quality of movement in a single mark. So you make a kind of a wiggle like this, and I'm just drawing it with my cursor, kind of allows you to perform this abstract animation. Each line repeats according to its own period, traveling across the screen space with, kind of looping boundaries, producing an ever-changing display of lively, worm-like textures. So this is a different kind of generativity where, it's really just reproducing my gesture, but to produce a kind of an abstract animation therefrom. And this is here, its lesser-known sibling called Bluetail. The code is exactly the same except for one line of code which happened by accident, and the marks move in a completely different way to allow for a completely different kind of gestural creation. So interactive installation art offers the possibility for the visitor to discover, as I mentioned, their own potential for creative actors. So during the early 2000s, I made many full-body interactive projections that used computer vision in different ways to govern generative images and sound. And this one was inspired by my mother, who's a painter. When I was small, she used to teach me about painting and talk about negative space, right? The sort of space, in, around, and between our bodies. This could be a difficult concept for a child. Nowadays, we have this kind of classic heart shape, which is our sort of default negative space that we can go to, kind of gang sign that makes the concept clear. So in the case here, it's called interstitial fragment processor. It's the 2007 offer, which highlights one's awareness of the negative shapes that are always around us, formed around our body, to generate ever-changing composition of lost poles. So, pink shape arose between people. So generativity based on gestural interaction points the way towards alternatives to today's text-to-X kinds of interfaces to AI. This is recent work by a former student, Joel Simon, which uses computer vision to track the motion of a visitor's hand in the browser, and then uses that information to puppeteer inputs to an image generator. This allows one to capture the subtlety of personal and complex motion in a way that language simply can't. A few other types of generativity, and I may just kind of accelerate towards the end here. The premise is that generative art really comes into its own when it has daily subscribers. For a little while, there was a kind of a golden era of Twitter bots where you could actually make software that would publish generative art every day on Twitter, and people would subscribe to it. And a fantastic example of this was Moth Generator, a Twitter bot that was created in 2015 by my former student, Everest Pipkin. This software used custom code to generate an imaginary moth every day and published it through a Twitter feed, and generated both the appearance using a kind of P5JS kind of coding, as well as a fictional name. Moth Generator created and served an audience of 10,000 followers. The software broke in the great Twitter bot purge of 2023, disabled along thousands of other spam bots, but it's a relic from a different era of social media and an object from a parallel universe of generative art. When we talk about generativity, we don't just have to refer to generating images. We can also generate behavior, not pre-canned scripts, but reactions that are developed contingently in and in response to the actions of a user, visitor, or participant. As you saw earlier with cytographia, I've been chasing a vision for interactive blobs for a really long time. This is me when I was a sophomore in college. Yeah, Yes, it's true, 1992. So my very first interactive artwork developed under the direction of Patty Mace at MIT. I was designing these kinds of blobs. A funny anecdote is that the blobs are following my hand, but as a result, I had to keep my other hand in my pocket or else the system would get confused. So it led to some very unnatural ways of moving. Another kind of project that from this, from 2000 in this case was on the left, a project in which a participant is using a single gesture to simultaneously specify both the shape of a blob and its quality of movement. And on the right is an interactive organism called Obzop that responds to gestures through generative character animation and a simulation of springy physics. So in terms of generating behavior, maybe I got mostly into this in my project Double Taker. It's a gigantic robot that lived on top of a building in 2008. It's a system for real-time character animation, specifically a double take. It tries to kind of look at you and then kind of look away and then look back like maybe it missed something. And it tries in this way to, express the idea that every sort of person who visits it is worth a second look. So inside this tube is an 800-pound industrial robot arm that was living on top of the roof of the Pittsburgh Center for the Arts during the summer of 2008. And there's a summer art class kids at the Pittsburgh Center for the Arts. So they would see this all summer long as they would enter to the museum for their art lessons. And this huge, slow, kind of stupid robot would look at them, a combination of like Big Brother and Sesame Street, kind of like responding to them in a slow way. There you go. It's unscripted, they're just waving at it. Quick anecdote. This is not a real, this is made by AI. One of the children attending the summer camp made an incredible crayon drawing of the robot with pink lasers coming out of its eye. And they gave it to me and I lost it. And a few years ago, a good friend tried to cheer me up and she used an AI to kind of recreate the drawing. It's one of the most thoughtful gifts I've ever received. And I encourage you all to use these prompt systems to make similar gifts for your loved ones. The resemblance of this fake is so close to my memory, it almost makes it hurt worse. Generativity and combinatorics. Talk about combinatorics. On the right is a set of playing cards from a 1965 game called Mixies, right? Based on the Victorian parlor game of the Exquisite Forks. There are 12 sets of interchangeable heads, torsos, and legs. On the left side, I've written a tiny program. That's the complete 28-line P5.js program to load these 36 images and generate new characters by remixing them randomly. It's written in P5 to do this, and a little bit of math will show that there's 1,728 possible combinations. Using just a few elements offers a large feeling possibility space, right? So it's a different way of thinking about generativity. This combinatoric approach underlies a great deal of contemporary generative art, such as the well-known CryptoPunk series of NFTs by Larva Labs. Each of these generated faces is a unique combination of different hairstyles and glasses, skin colors, mustaches, and so forth. The entire collection has made more than $2 billion in total sales. But let's take a moment to consider what's possible with combinatoric generative art, right? This is just one way of thinking about it. Here's the beginnings of something I want to share with you, not by me. But it's an idea. Can a drawing contain a kind of absolute truth? I submit to you that there's a way it can, with exhaustive combinatorics. These here are the only two possible topologies by which three things can be connected, not counting configurations in which a point is disconnected, right? So in such depictions, generative rules are executed to their logical conclusion. The visual forms that result are no longer the arbitrary product of human imagination, but something more like the fundamental, irreducible property of the universe itself. So here's with 4 points. Here's 5 points. And here are all possible graphs of 6 and 7 points, respectively. In these depictions, generative rules are executed to their logical conclusion. The visual forms that result are no longer the arbitrary product of human imagination, but something more like the fundamental, irreducible property of the universe itself. Hopefully, many of you know work by Sol LeWitt, who helped pioneer the ways in which such rule sets could be considered artworks. This example is of 122 frame structures, which depict all possible combinations of cubes with missing edges, such that the structure stays three-dimensional and connected. There are no other possibilities. All possibilities have been generated, and none are missing. And here's a few more generative systems, much more recent work conceived by Michael Fogelman. On the left are all of the ways of dividing a 5x5 square into integer-sized subsquares. And on the right, all the possible ways to mow a lawn, which is 7x7. Right, so you've got a lawn 7x7. These are the ways you can mow it. That's it. Period. That's all of them. These generative approaches are instances of what's called a minimum inventory, maximum diversity system, a term coined by Peter Pierce in his 1980 book, Structure is in Nature as a Strategy for Design. So this kind of approach describes a kind of kit of modular parts and the rules of assembly. It gives you maximal design bang for your formal element buck. Nature excels at this game of using very simple elements to generate profound and surprising diversity, right? So I'll describe one of my own brief contributions to this line of thought, a project that Clement mentioned, which was inspired by the needs of my then young son, who's now a first-year student here. So, you know these, right? These are construction systems, right? You know these, you grew up with these things. Each one presents its own universe, and they kind of pretend that the other universes don't exist, right? They would prefer to be your only kit, and the others are just elephants in the room.
In here, and like a car, this, then that.
Okay, this is what kind of way? This is what kind?
No,
What the other,
inventory.
and do they fit together?
No, my thing is that they're going to make R and is kind of like this.
So wait, so what, that's kind here,
So,
so you're trying to connect what?
this is
The three different systems that they fit together.
that's what I'm trying to figure out. Yeah.
That's the problem, right? Challenge accepted. Today's manufacturers have little or no incentive to kind of make their products intercompatible with anyone else's. Indeed, despite obvious benefits to users everywhere, the implementation of cross-brand interoperability can be nearly impossible, given the tangled restrictions of patents, design rights, trademarks involved in doing so. So we stepped up, and in 2015, we created this, the Free Universal Construction Kit, which is a set of adapters between 10 different popular children's construction toys, and allows any piece to mate with any other, and it encourages totally new forms of intercourse between these otherwise closed systems, enabling radically hybrid constructivist play and the conception of heretofore impossible designs. So it implements proprietary protocols in order to provide a public service unmet or unmeetable by corporate interests. These designs are open source, and you can download them. Anyone with a 3D printer can sort of download the files and print a copy for themselves. And they actually work. And there's even a universal adapter brick that allows all 12 sets to connect together. And for this, to me, that represents this kind of idea of engineering and reverse engineering as a kind of civic activity in which everyday people create local solutions to local problems and creatively overcome the limitations of mass media. I should really wrap it up, so I'm going to kind of leave it here. I got much more, but it's a long night. A quick anecdote is that I could never have created this project had I not joined a collective of sort of pranksters and provocateurs known as the Free Art and Technology Lab. And this kind of group gave me the courage and the sort of thinnest veneer of anonymity to release projects like that. And it wasn't just because of the kind of gray legal territory in which this kind of kit operated, but it was the fact that this Free Art and Technology Lab gave me permission to sort of jettison my identity as a creator of the kind of work I'd previously built my reputation around. So it's great to have a posse, and I encourage you guys to find or make one yourself. Let's race through the rest of the talk, and stop me if you want to know anything, but in respect of your time, I'm going to wrap it up now. I've been teaching my students to use plotters. You guys are doing the same, and I'm thrilled to see that you guys are doing that here. It's a great way of encountering real material conditions, and I think it's something that's necessary. It's kind of touching grass. It's a great way to come back from the pandemic. It's a great way to get off the screen, and I think we're really hungry for it now that we've grown up with screens and need to kind of move away from them. You know, we suddenly have to deal with the real mechanical circumstances of the world, and you know, even like the randomness of nature. So let's see here. I'm gonna skip through the kinds of plotter experiments that my students are doing over at CMU. These kinds of like body horror, you know, piling patterns, or these kinds of like systems that are drawn both by a human and a computer at the same time. Generative comics and these kinds of huge printed diagrams generated by code that give people instructions for how to relate to each other in social spaces. I'm going to skip this. I'm going to skip. I should show this, and I'll wrap it up. Last project. Very good. Excellent. Wonderful. I want to show one project here, which just thinks about AI in a different perspective, and then I'll wrap it up. Last project. A lot of the way we've been thinking about artificial intelligence is in its generative capacity, its ability to sort of synthesize new media, new images, new sounds, or what have you. And that's great. And as creative people, we should do that. But something that is kind of important about AI is that it also gives us the ability to understand media that already exists. And it can provide insight, particularly into large collections of media that we might want to understand. So project that I worked on with my students was a 4-year collaboration between my lab, Studio for Creative Inquiry at Carnegie Mellon, and the Teenie Harris Archive at the Carnegie Museum of Art. So Teenie Harris was one of the sort of possibly the foremost photojournalist documenting African-American life in the 20th century. It took over 80,000 photographs of Black life in Pittsburgh between 1930 and 1970. In a career spanning like almost 5 decades. And now his life's work has ended up at the museum down the street from my school, the Carnegie Museum of Art, and they're trying to go through his life's work. So there's some issues with his life's work. The negatives have been badly organized, meaning they kind of got shuffled after his death. In many cases, they were not annotated by any kind of metadata at all. And the museum is trying to go sort of very tediously go through these 80,000 images with some of the few surviving people who are still alive from the 30s, 50s, 70s, to kind of say who's this and what's going on here and what's going on in these images. So we collaborated with the archival team at the museum on a series of software tools to help their archivist annotation work. And along the way, we produced this kind of interactive installation that I'm going to show you that made the collection visible to the public in new ways. So here it is presented in their Teenie House Gallery, which was a space dedicated to his life's work. Here it's used by visitors. So there are these ways of organizing clusters of images using AI that we see sort of here, where by giving it a set of images, and this is some student work organizing, for example, images of clouds or images of Japanese prints. Like we can automatically cluster things using image analysis, using AI techniques. And we began to use this as a way of approaching the Teenie Harris Archive to help organize it and to make discoveries about it. So one student, Zaria Howard, who's shown here, at the time she was a sophomore, was particularly interested, and she basically became the principal investigator of the project. She was double majoring in art and machine learning, and the project sort of dovetailed directly with her interests and became a long-term investigation that lasted the rest of her undergraduate career.
Harris is this extraordinary photographer who worked for the Pittsburgh Courier from about 1935 to 1975. And during that time, he's going to be documenting the everyday life and creating this really complex chronicle of what it means to live while Black in America.
After his death, his negatives eventually made their way over to the Carnegie Museum of Art, where for the past 20 years or so, they've been kind of sorting through and figuring out this amazing archive. About 4 years ago, we formed a partnership with the Carnegie Museum, and we began to say, like, would it be possible to use some advanced technologies to help facilitate the organization and analysis and annotation of this archive? And in particular, we were interested in the promise of using advanced computer vision algorithms and new deep learning and machine learning algorithms to sort of figure out what was in these images and maybe find connections across the images that maybe hadn't been discovered previously.
So now patrons, as we're having any kind of programming, would be able to browse through the collection, through the entire collection, all 60,000 of the scanned images with the power of play.
A lot of times when photographers and artists are shown, it's only
key individual pieces or like highlights and things like that. The ability to be able to look at an entire collection of an artist's work at once and really get a deeper understanding. It's really powerful to be able to see all the stories that an artist wants to tell.
So here we can see some of the different ways that the project organizes the archive. Keywords, year, estimated age of the subjects, number of people in the photo, and on the right, sort of navigating the kind of the clusters of banquets or caskets and car crashes that form subjects that covered in his daily photojournalism. So it would group like images together. So all the people having dinner together, all the car crashes, all the interior scenes, all the kind of basketball games, were all kind of grouped together by the system so people could kind of see these connections in the work. And here are some of the kinds of annotations or metadata that the system was able to pull. So interesting, and I'll leave it there. Okay, so it's important to say that a number of people pictured in the museum's archive are still alive or who are living relatives of people that appear in the photos. The man is pointing at a photo of himself from the Vietnam War era, which is a really unusual situation when you're represented in a photograph that's in the museum. And there's also some content in the archive, such as nudity, that some members of the public might consider controversial, right? So all this gets into complex territory when, with support and encouragement of the museum's archivists, we began using face recognition to across the archive in order to kind of do identity chaining, right? In order to exhaustively find all the faces across the archive, we use sort of 5 different algorithms for kind of finding all the different faces. And remarkably or unsurprisingly, it worked pretty well, right? It simply put, our tool can help an archivist identify people who might appear across multiple photos. I say might because in addition to the usual inaccuracies, a system could also get confused by siblings who resemble each other, or a child in 1960 who looks just like their mother in 1940, right? And so here's an example of sort of face recognition and change, right? So we choose a person, in this case, this person here, double tap on her face along with the orange rectangle, and we find other faces with that same person in other photos. If you sort of select one by double tapping it, it's going to jump across the archive to another photograph with the same person, right? That's kind of identity chaining across this. So there are interesting challenges related to working with this material that shaped our project: sensitivity and subject matter, right? It documents real people, many who are recently deceased, but also many who are still alive. And it focuses on the lives of Black people and the history of the close-knit Black community in Pittsburgh. And we have to acknowledge the sort of fraught histories of the depiction of persons and communities of color, right, in the United States, especially in relationship to computing. For example, how machine learning technologies such as face recognition have been used and abused in the context of domestic surveillance, carceral geographies and law enforcement. And in light of this, many different considerations have been and must continue to be taken regarding how this data is used and labeled and de-anonymized. So here, we have to, with respect to the privacy of depicted individuals, the lens through which a community wants to see itself, and with respect to the possible perpetuation of racist stereotypes or algorithmic bias. So here's the screensaver mode of the project, which displays when nobody's using the exhibit, and it slowly moves from face to face. And this kind of pointing, just focusing, using face recognition just to kind of like focus on individuals, in a scene to kind of understand who's there and to kind of dwell and give us a moment to just kind of appreciate person's personhood. Is I think one of the best aspects of the work. So this is certainly a territory which I'm trying to tread lightly and in close consultation with the museum's archivists, who themselves have worked carefully to kind of build trust with the communities that they're representing and who appear in the archive. So this is where I end. This is the sort of the flip side of all this. This is Teenie Harris's own grandson and great-grandchildren browsing this archive of photographs, essentially their own family archive in some ways, which depict many members of their own family and neighbors. And so all these tools sort of brought to bear in such a way as to allow them to see and generate new connections in their own histories. So thank you very much for giving this. Everything. We have 10 minutes for questions or so, and then or a minute or two. I'm not sure.
Yeah, 10 minutes to stay.
Yeah. If there are questions,
What
Sorry.
happened to the Institute for Creative Inquiry? What happened? It's not working anymore? Is it over or are you?
I had 2 7-year terms as director,
Oh, it's
and I know it still goes. It
okay.
has a new director. It's-
Okay.
Yeah, there was a change of dean, and the dean appointed a new director at the beginning of when she got hired.
Got it. Okay.
So she's like, she changed up all the no, the Studio for Creative Inquiry, also, I did not found it. It was founded in 1989, and I was privileged to direct it from 2009 till 2023 or so, 2024. Yeah, and then during the pandemic, it just was time for a refresh, and the same way that departments get new heads. Yeah, no, it was a great opportunity and privilege to direct. It has a new director, Nico Ross, a professor of drama, video and media technology. They've been directing it since 2023 or 2024.
Okay, so it's good to know that it's still up.
Oh, it's still going for sure. Yeah, no, it gives grants and it brings artists in residence and it supports new media art research for sure. Yeah. Yes. Question. Oh, I thought you were raising your hand.
Oh, yeah. I'm wondering, are there any ways currently where human generativity the process of human generativity is being combined with the processes that large language models might be using?
I mean, sure. I mean, plenty of people are using them for all kinds of things, right? Like, I mean, poetry, for example. I mean, the work isn't that good yet, or may not ever be good, but I don't know. I mean, I'm not sure what you mean by human generativity and so on. I think we've all used large language LLMs for all kinds of things, right? I mean, and hopefully you use it to make something good. But you can certainly use it to make something bad. Yeah.
I guess what I'm interested in is I feel like in my own creative process, I'm an industrial design major. In my own creative process, I'm really interested in form development.
Mhm.
And I feel like when I try to practice that, I'm not really consciously drawing out the shapes. I feel like there's some sort of process that I'm unaware of, that's subconscious, that's happening. And I'm wondering if there's a way, I guess if there are any projects right now that are sort of combining maybe the language that I would use personally with the process that a large language model uses to generate images.
There's plenty of work like this. I think people are definitely looking at computers for form generation for sure. We have a program in my university called Computational Design Graduate Program in our School of Architecture, where people are using artificial intelligence in various forms to kind of synthesize 3D models. The generation of 3D has recently become kind of commercially accessible. Like you could all use Comfy UI to generate 3D models from text prompts. The models that are generated are not necessarily attractive or watertight for 3D printing, but they're certainly interesting to look at and explore. Again, it's just kind of like average garbage forever. Like do you get good stuff? I can't tell you, and how do you make things that push out towards the edges of what's new and interesting versus kind of replicate things that have come before. Depends a lot on the training data. But certainly people are interested in 3D modeling with form. And I think it has all the problems of image generation that we know about already from how we see AI-based images in the world. It's there's going to be good work, there's going to be terrible work. Yes.
Almost off of that question, I kind of thought of something. I'm interested in your opinion on per se LLMs versus other foundation models. And today in the workshop, you were talking about building your own AIs and these kind of things, or maybe small models rather than large models.
Yeah.
And just
I love small models, and I think it's too hard right now to train your own data. But I just taught a generative art class this past spring, and one of the assignments the students loved the most was sort of training their own tiny models. One of the sort of sad things about the kind of state of affairs right now is that really interesting algorithms from 5 or 10 years ago that you'd like to use that ought to be really easy to run on current hardware are incredibly hard to get working again because the libraries have all changed in the meantime. it was incredibly difficult to get a 2015 era GAN to work on 2025 era, machines, because all the libraries are broken and nobody's, wanting to fix it up to pick up the pieces. But those older algorithms are fantastic, in that they produce weird, glitchy results with lots of flaws. And this kind of push towards photorealistic advertising has really kind of like stepped away from the kind of the weird possibilities of these kinds of hallucinatory kind of like perceptually interesting spaces that kind of left behind. I do miss them, and yeah, I mean, you can get the old stuff working, or if you can find enthusiast communities who are like, yeah, we want to make GANs work again. 10 years later, you get great results sometimes, and the result is not to make something that tries to look like something real, but to make something that tries to look like whatever the heck it is, and weird stuff. I think, yeah, I hope that gets your question. But yeah, someone earlier asked about like how do I train my own data? There's ways of doing it now. You can make what's called a LoRa, which is a way of training your own data set, but it's you can use like between 20 or a couple hundred images. You can make your own LoRa. It's not really training your own data set, because what you're really doing is you're sort of helping guide a pre-existing model to kind of find a cranny in its latent space that maybe is underpopulated, and then you populate it with the images you want to have. But you can then thereafter synthesize stuff which is more like this, please, more like what I trained with. But that's the sort of the latest way that people are doing it. But you can't. It's difficult to kind of just train something from scratch on your own little data set. It's the world's moved on to these gigantic billion scale data sets, and you have to kind of have a great deal of expertise to step outside of that realm. Yeah. Other question? Maybe I should take one more. Yes, Megan.
You are exactly who you are, but you're a RISD student. What classes would you take? You still know everything you know.
If I were a RISD student, what classes would I take? I'm afraid I don't know your curriculum well enough. I would take Travis's plotter class on Fridays. That's for sure. That's 100%. My students came back from the pandemic, really needing to touch grass, and it was exciting to kind of teach them to use the plotter for generative art, because they've just been on Zoom and screens for 3 years in isolation. So to suddenly have them kind of like working with real materials, was really exciting. And I think that's a great direction now that you guys are back in real space together. And, use your brains to control machines to do interesting things with art supplies. That's what I would recommend.
That's a good.
Yeah. Thank you.
Water professor had a question.
Oh yeah, Travis.
You said the more like this, please, is something I think about a lot. It's just like when you're making generative art. Like, how often does more like this, please, lead to something new in your experience?
Yeah, I think you have to come to it without if you have to come to it without expectations, or at least you have to come to it with the possibility of serendipity happening.
Yeah.
I think that if you approach it with like, if you have too careful of an idea in mind about what you want to achieve, then you won't be surprised yourself. So you have to find ways to kind of leave it open, and that is a challenge. How to design systems that are open-ended enough to surprise yourself is still something I'm still trying to figure out. It's not much fun to just make something that generates things that they're going to look like, right? And that's not fun for you, nor is it fun for people who are looking at things either. Yeah. Good luck, everyone. With your